Yes, it's great to be here this week with these language designers. The people in this row are here because they have made some excellent decisions, and the decisions have really paid off with excellent languages. And we want to take this opportunity to get in their heads a little bit and understand what it is that made the languages great. So the first question that I have for the group is, what business problem or what problem motivated you to play the role that you played in creating the language?
You starting? Yeah. You want me to start?
Yeah. Sure.
Okay. So back in around 1990 when I started Python, I was working my way through a lot of code that I had to write. And I realized that I only had two languages that I could use. I could either use Shell or I could use C. And neither one was the right language for the kind of applications I was writing. I wanted something that was a little more sort of expressive than C, and yet not so slow as typical shell scripting. And then I combined that with sort of nostalgia for a language I had helped implement half a decade earlier. And I combined some good ideas with some ideas that I thought were not good, where I sort of implemented the opposite features. And apparently that worked out quite well.
Okay, so I'm one of the many people who worked on Haskell. And we decided to design Haskell in 1987. And the reason for that was that in the research community in functional programming, there were kind of two camps. There were the camp that I belonged to that liked lazy evaluation, and the camp that preferred strict evaluation. And strict, that means, that's what Erlang has. So on the strict side, people had ML. One standard language that so many people could work with. And we were a bit jealous of that on the lazy side, because on the lazy side, you had as many programming languages as there were researchers, more or less. And we felt that that was holding the field back because it was hard to collaborate. And so we thought they're all much the same. So all we need to do is just design a language with the common parts. Nothing controversial, just put it together. It'll be quick and easy. Oh, little did we know. And that'll help the field move forward. So that was really the motivation. We wanted one true language to rule them all. But actually, there was a dominant lazy functional language at that time, and that was Miranda, that was designed by David Turner. And I really want to give David a huge amount of credit for his brilliant language designs that were very influential on Haskell. And indeed, we asked him, can we use Miranda as the language for teaching, for research? We wanted a language for applications too, but I think teaching and research were the big motivations. Can we use Miranda as a starting point for the work in our community? But David was, at the time, running a company, and he was trying to promote Miranda for applications. He wanted control of the language. He didn't want 1,000 flowers to bloom. He wanted it to be portable, for there to be one true language that he could control. And so he said no. If he'd said yes, Haskell would not exist. But since he said no, we had to design a language of our own. And so one of the big goals for Haskell was not to be Miranda. Basically, a language for teaching and research. That was the priority.
Interesting. So I was actually privy to be a fly on the wall for a conversation between, I think it was Joe Armstrong and David Turner at CodeMesh. And during that conversation, David Turner looked at Joe and said, I'm very surprised that you were able to get the reliability out of Erlang that you're able to get without strong typing. So I very much feel the connection to this whole family, to David Turner and Miranda.
Yeah, so David Turner had originally designed an untyped lazy functional language called Sassel that was very, very influential before he made the Miranda design. he has had a long history of being extremely influential in this field.
Wow.
Yeah, it works. Yeah, so we were originally out to solve a problem. Okay, so we had the telecoms type applications problems, and our goal was to work out how could we best program these. We originally weren't out to design a language. So we were looking at solving these type of problems, and we found that nothing really worked. So we started on something, which in this case was Prolog, and we were adding things to it as we saw necessary to solve the problem. And the problem in this case, the fundamental properties of the problem are still, for that matter, it's extremely concurrent. And it has to be fault tolerant. If we could not design something that couldn't handle the concurrency and in which you couldn't build a fault tolerant system, it just wasn't interesting. So these were two properties we had to be able to, the language had to be able to handle. And it became a language. So it didn't start out functional. It became functional. Someone said, oh, you've designed a functional language. And we sort of said, have you? Oh, yes, we have, haven't we? And, sorry, is Carl still here? Sorry, we didn't start off to make it actor-based either, because we were trying to solve the problem, and we ended up having processes. We ended up having asynchronous communication between processes. And it was basically the actor model, and again, someone told us we implemented the actor model. So we go out and read about the actor model. Yes, we have implemented the actor model. And that was the basic the goal behind the language, do that, to solve this type of problem. And we were originally quite restricted in the type of applications we're doing, telecoms application. And then it grew, and I think when other people realized they had actually had the same requirements, that's when it started growing.
So how many of you have heard this story before?
Some have, yeah.
Yeah,
Well,
almost all of us, right?
There's more that have heard it.
And yet, these are some of the most popular keynotes at the Erlang factories, Erlang users groups. I mean, it's almost like as a kid, you know, tell it again, tell it again.
No, we won't. No, we won't.
It's important to us, you know. It's written in our psyches. So, yeah.
Cool. So I had a mostly imperative programming background, and I was starting to tackle concurrency because that was 5, 6 years ago, and then the tools that we had in those programming languages, they were very frustrating, and I knew at the time concurrency was becoming more and more important, and I wanted to write software that was going to use all the cores of my machine, be it my local machine or the production machine, as efficiently as possible. So I was hitting this wall, right? And I decided, okay, I need to find something. I need to find the proper tool to do this job because the tooling I have right now is just not good. So I went out to explore what other programming languages, what other communities are doing, and I eventually found out about Erlang and the Erlang virtual machine. And I heard exactly this story, and I fell in love with it, right? There is no way, right, to not fall in love with it. The story Robert was just telling. And you know, during this research of, you know, what is this language, what is this tooling I want to use to write my next software, I was very fortunate to explore and study a bunch of different programming languages. And when I came to Erlang, the Erlang virtual machine, I felt I could bring many of those ideas that I found in this exploration into the Erlang virtual machine. And that was what led me to, you know, create Elixir, right? Like, what if we bring all those great ideas that we see elsewhere into the Erlang virtual machine and expose the virtual machine and the runtime in different ways, and where we can go from there. So that was the...
Now, you've made it a very strong point to maintain Erlang compatibility. So how important to the Elixir language is the connection to Erlang, the Erlang compatibility?
Yeah, so that's one of our main assets, right? So it's funny because when I was first starting work with Elixir, and it was not even planning to like be an actual language, just a prototype, was having fun, right? The first prototype was like extremely horrible, exactly because I was somehow able to break hot code swapping. I don't even know how I did that, right? Because I was like pushing.
I'm impressed, right?
Yeah, like, so there's a badge for me somewhere because of that. So and then eventually I said, like, wait, if I'm doing this because of the runtime and the virtual machine, this needs to be a goal. So it's extremely important, right? It's one of our main assets.
So Guido, I have a special question for you. So we talked today about a friend that I had that's learning Python, and it's a big influence on his life now. But it struck me that Python has been an excellent language for teaching. What do you think it is about Python that makes it an excellent language for teaching?
The funny thing is that is almost an emergent property of Python. So I, like everyone, I try to emulate another language that I was a big fan of that didn't make it. In my case, that language was named ABC. It was invented by one of my great mentors, Lambert Meertens. And ABC was intentionally designed to be a very teachable language. And they sort of, he actually took, he did not sort of say that ABC was exclusively a teaching language because that felt pejorative to him. But it was easy to teach as well as easy to use. And I sort of copied enough syntactic and semantic and interactive features from ABC into Python that 5 years after Python was sort of released to the world, I started hearing from people who said things like, my 8-year-old is using PC and programming it in Python. And by the way, he found a bug in it. And that sort of, and I said, wow, that's great. I didn't plan it for that, because as I started my origin story, I was a professional programmer, and I wanted a third programming language in the middle between C and Shell. So I did not have the educational market in mind, but maybe that sort of helped give Python some respect in the academic, in the educational market, because they're also afraid of teaching languages that are only good for teaching.
Yes. So I have a follow-up question for each of you. We've heard a little bit about each language and the goals that you were pursuing to make them successful. Can you give an example of a language feature that you think shows that decision-making in process, or in action? And we'll go the other way this time.
So I'm going to skip anything that the virtual machine and the runtime gives to us, but I think one of the main features in one of the main features in Elixir is the protocols that we got from Clojure, and it brings the idea of, it brings data type polymorphism into Elixir. And what it allows, that allows developers to define APIs and define code that is extensible, right? You can write a code and say, hey, you can give me any data type that you want, right, as long as it implements this particular protocol. And that was one of the missing puzzles, because we have module polymorphism in Erlang, in the virtual machine. We have process polymorphism, right? When you send a message to a process, you don't care which code that process is running, right? You don't care anything about the process, like what is in its message queue. You just care that the process know how to handle that message according to a given contract. And bringing that to data types, I think, allows us to really, write code that is extensible, that developers can take that code and say, hey, I'm going to teach this code now how to work with my data structures or how to work with my code base. And then they compose, right? Right,
right. So it strikes me that you have always given credit to the language that you found a feature from. I've heard you mention C#, now Clojure and Erlang, Ruby, on and on and on. Are you a language geek?
Yes.
Yeah. And what about for Erlang?
It would definitely be the concurrency in the error handling features. I mean, if you seriously look at Erlang, the sequential Erlang, most of what's in there is pretty standard functional language. I mean, if you program sequential Erlang, then you go look at Haskell, you will recognize a lot of things going in there. Haskell has a big type system we don't have, but the basic methods of using exactly the same. So I'd say the sequential Erlang language is simple functional language. The big bits are the concurrency and the error handling and the primitives for doing that. And if I want to boast a bit, I would say that's one of the things we got really right. If you look in the concurrency, there are 3 basic principles for the concurrency and 3 basic principles for the error handling. And with that, we can build everything on top of it. I'd say that's the most interesting bits of the language as such.
So one of the things that I often hear from object-oriented developers coming to Erlang is, I expected something so reliable to be to have static typing. What would you say to that?
I would say we can build so reliable systems you don't need static typing.
Yeah.
So yeah, seriously, static typing would introduce some problems, say, with the dynamic code handling.
Do you guys remember the Let It Crash t-shirts from a couple of years? Was it last year or a couple of years ago? Last year? Do you guys remember Francesco's story about an army of the Erlang Solutions guys getting onto a plane with the Let It Crash t-shirts?
Yeah, of course. The thing to remember with Let It Crash is that, yes, you have a system around you which can handle your crashes, right?
Right.
That's the important bit.
And for Haskell?
Can I give 2 features?
Sure.
So the first one is I already mentioned that we had some ML envy. So we really wanted to have type inference. You know, the idea that you could have compile-time type checking, strong type checking, but not need to write type declarations on all your functions. That was important to us. And we looked at ML, we thought that's great, except that in ML, if you write something like, increment x equals x plus 1, ML doesn't know what kind of number you mean. So you have to say, well, do I mean the integer one or the real one? And we thought, oh, that sucks. So to get around that, Phil Wadler and Steve Block came up with the idea of Haskell classes. This is the way that Haskell does overloading. And it was really basically to solve this problem with numbers, so we wouldn't have to put in int and float explicitly. It's a very small problem, but we put that feature into the language because it seemed like a nice one. And when it went into Haskell 1.0, it's been in since the start, it was a very, very weak and powerless feature, but it was an entirely new way of doing overloading in programming languages. And it turned out that you could write a bazillion papers about how to make that stronger. And remember, our goal was to be good for research. And we really achieved that. If you look at the functional programming conferences over the years, the number of Haskell papers just went up and up and up and up and up.
And the number of PhDs too, no doubt.
Absolutely. And if you look at what that has turned into today, it's turned into a fully programmable type system. It's a long time ago since that you were able to start running Prolog programs, basically, at compile time. And that has, having a programmable type checker has fueled a lot of the research that has been based on Haskell. So that was one really important feature.
Which is now taking the next step with Idris and Agda and languages like that.
Well, yes. Well, they have a separate genealogy.
Yes.
But, yeah, Haskell is really a lab for practical type system experiments. And that's been very important. So the other feature that I wanted to mention was that we were absolutely uncompromising about being pure. If anybody had said, well, can I just have a function to print an integer, we'd say, no! And we had to, because of lazy evaluation. With lazy evaluation, you write code in a certain order, it might execute in any other order. So, if you were throwing calls of IO format here and there in your code, your output could come out in any order or not at all. And that's really not useful. And that forced us, first of all, we had a very, very clunky way of doing I.O. Haskell 1.0, you couldn't really do I.O. in any sense. But we didn't care. But that led Phil Wadler to bring in the idea of monads. And once again, the first version of monads in Haskell was quite weak, but that idea was an extremely powerful one. Nowadays, everybody who learns Haskell writes their own monad tutorial afterwards when they finally understand these things. And that idea has spread beyond Haskell, so you find async monads in F# and C#. So that insistence on purity forced Haskell designers to find new ways of doing things, and some of those new ways have turned out to be really influential.
And so many of the Haskell ideas are trickling out into the language design community. As I wrote the 7 More Languages book, so many of them mention Haskell as a deep influence. And I think that's a testament to the things that have gone into Haskell. And what about for Python?
Oh, for a second, I thought you were going to say that Haskell had turned into a fully programmable PhD factory. And Python has absolutely nothing it owes to Haskell. Because the feature I actually was going to bring up as the sort of Python's defining feature is that everything is only runtime typed. Python is completely dynamically typed. The compiler has absolutely no clue about the type of any object, variable, or whatever. And even if the type is obvious, like you see an integer literal in the source code, the instant it has parsed it, it essentially forgets the type and just says, well, there's another object to pass around. And this has sort of led programmers to commit unbelievable feats of dynamic programming without actually the need for dynamic syntax, because Python's syntax is as sort of mundane and static as in any language. And so that combination of features feels like Python's defining set of ideas.
So at this point, you had a
point. The story John told about type classes, it's very interesting because to me it's like one of the most interesting things about language designs because, as everything else, sometimes we have good ideas, sometimes we have bad ideas. And, we have a problem, we need to come up with a solution, and then sometimes we try a solution, it's a bad solution, we need to throw it out, start it again in 6 months. But sometimes we have a problem and we think, oh, I think these type classes can be a good solution to this problem. And then it grows way beyond we have originally thought, and that's just fantastic, right? We see people using it, taking this idea, and then you look at it and say, whoa, I didn't know they could do that, right? And that's like one of my favorite things to see, those small things grow and go further.
Yeah. Well, I think that's why we're here. But I think at this point, I don't want to take the time to ask all the questions. I think we'd like to open up the questions to the audience. Francesco, are you going to run?
Can I just make one comment both to
Certainly.
These 2 languages? We explicitly did not go lazy. I was toying with the idea for a while, but one of the things we had to do, we're controlling hardware, then it's very important to know when and in which order things were happening. So we just could not go lazy. And if we had lazy, we'd have eval calls everywhere forcing evaluation, so it'd be a pretty waste of time.
Unless you have monads.
Well, okay. We use message passing for monads, right? Instead of monads, we had the message passing for that. So we weren't into that. And yeah, I agree with Guido about dynamic typing. Yeah, that's that's it. That's it. But I can just say one thing. We were purposely very explicit in the language about everything. So there's very little implicit anything. It's very explicit what's exactly going on in the language. And that was as a goal in itself.
Are there any questions?
I have a question to John about laziness. So one of the problems that kind of intuitively are felt in laziness is that it's very hard to kind of introspect and debug the system that is using lazy evaluation. So do you think there are ways of actually observing whatever is happening in your system aside from just seeing some thunks generated?
Yes, sure. So you have to debug lazy programs in a different way. So first of all, when you're debugging, you try and think about, okay, what order are things happening? You try and work it out. You start looking at stack traces. I remember when I was a doctoral student, I looked at stack traces from lazy programs, and I thought, what? What is this stuff? And those techniques, they just don't work. But what you have to think about is, what are the arguments of a function, and what is the result? So you just think about the purely functional behavior, never mind what order they get computed in. And there are debuggers for Haskell that support that view of functions. There's something called HOOD, it's quite old now, the Haskell Observational Debugger. You can put a trace on a function, for example, and then you'll see afterwards, okay, this function was called 10 times with these arguments and gave these results. You don't see the order, you don't see any stack traces, but you see the input-output behavior. So if you think about that, then actually once you realize that you don't need to know the evaluation order, it's a kind of freedom. And you can debug in, you have less to think about. That's always good.
More questions?
I have to admit I'm a big fan of Haskell and second to Erlang. So I was curious, you said Haskell started top-down and then Erlang kind of bottom-up type of architecture. So is it possible they're going to meet somewhere in the middle, so you maybe add some typing in Erlang and inherit some of the good things from Haskell?
That's a tough one. We could perhaps steal ideas from Haskell. I'm not averse to stealing ideas from anything, right? That's no problem. I think in some ways they are so different, it'd be very difficult to merge them. I mean, Haskell has a fantastic type system, but the way the Erlang system works at a low level, I don't think we could incorporate that. I mean, we have this very dynamic code handling, so basically you can reload any module with anything you want. And I don't know if you could make a type system that could handle that complete dynamic nature of it. We do advocate trying to code cleanly. I mean, the more functions you write that are pure functions, the better your code is going to be. That's going in a similar way to the Haskell world. And I think that's just a very good rule, right? So in our case, if you're doing message passing, which is our way of doing side effects, try and limit that as much as possible. Try and make much of the system as pure as you can. That's not incorporating directly ideas from Haskell or anything or merging, but just taking some of the good ideas, common good ideas for that. But anyway, that's my view.
Yeah, so first of all, I think it's important to say that, we might say, well, Haskell, Erlang, very different. But, from a certain perspective, they're almost the same. You're going to call me an idiot now.
Yeah. No.
Yeah, so from a sufficiently far perspective, they're really very, very similar. And I mean, my experience, I use both, is that moving between the two, you can carry a lot of ideas backwards and forwards. So we already have a lot of shared mind share from that point of view. And then if you look at what Haskell can learn from Erlang, well, as Robert said, the distribution, the concurrency, the fault tolerance, those are all really excellent ideas. Many languages have stolen them, and so has Haskell. There's something called Cloud Haskell that is designed to provide the same kind of model in Haskell. We just had a talk about integrating Haskell nodes into an Erlang system.
Right. I
think it would be really cool if you could run something that would look to Haskell like Cloud Haskell and look to Erlang like Erlang distribution and just plug them together that way. And that might well work. I think the other thing that could be done is one could design a language to run on the Erlang VM with a Haskell-like syntax and a Haskell-like type system. You couldn't do everything that Erlang can do in that. Hot code loading, for example, is going to be a problem. But you could imagine using something like that for writing parts of your system where you can type check successfully. I said that to my son, who's studying computer science at Chalmers, and his bachelor's project is trying to implement it. So, maybe we'll hear about that in the future.
All right, yeah.
Very cool. More questions? Well, let me hijack the mic for a second. So I've got one. So my question to you is are there certain areas where features have surprised you, where the usage maybe went in a different direction or had a different weight than you expected when you created the language?
I think the first time that really happened to me with Python was when people started embedding Python in other application systems. And that was just shocking for me. I had anticipated that you would write C extensions and link them into Python, and I was sort of dabbling with dynamically loading extensions, but it had never occurred to me that you would load Python as just one more library into an even larger programmable system. And that actually shaped a bunch of deep changes to Python's runtime to make that more easily possible. And this was like in the early, mid-90s.
Anybody else?
So I think one surprise was certainly how far the class system in Haskell turned out to develop. But I'll take the question slightly differently in terms of was there a feature that turned out to be a mistake?
I didn't want to ask that, but
So when we began to discover how nice the Haskell overloading really was, then there was a move to start overloading more and more. For example, you might want to overload strings or overload booleans or overload lists. And in Haskell 1.4, the fourth version of the language, then we had overloaded a lot of the basic list operations. And what happened suddenly was that whenever you wrote a program, so the type checker needed some fixed point. It could be almost anywhere. It could be, in Haskell, you don't overload something on its arguments necessarily. You can overload it on the result type that's expected. But somewhere, there needs to be a fixed point that tells the type checker, what on earth is this supposed to be? And in Haskell 1.4, we took too many of those fixed points away. And as a result, you'd write your code, simple little code that would work perfectly well in Haskell 1.3. And the type checker would say, what is this? It's ambiguous. Please tell me. And suddenly, you had to start writing types all over the place again. So that was something that we rolled back in Haskell 98. And I think it's a result of a tension that has appeared several times in Haskell's design. And that is that the designers of Haskell, there's always a Haskell committee working with it, they're real Haskell experts. They're like the super nerd Haskell hackers. And if there's some feature that they can see how to use, there's a strong temptation to put it in. But it's easy to forget what impact that may have on the first-year student who's just trying to learn how to write programs in the first place and write something and gets an error message that there's no monad instance of something or other. And they haven't a clue what it means. So there is that tension that you need to keep the language simple enough for simple programs that people can actually pick it up and start learning it without encountering consequences of all of the advanced features that have been packed in there.
Right.
I would say, as I said, we had a very restricted view of what we were designing Erlang for. But then the type of properties those systems have are actually quite general. But I was very surprised when you're seeing Erlang being used for things that we didn't even know existed. So I'd say most of the applications that say people in here are doing with Erlang are things we'd never dreamed of from the beginning. I mean, the first web server written in Erlang, I mean, why would you want to write a web server in Erlang? I mean, and these type of things for it. So that really surprised me anyway, right? And that I can just say, as a comment of most of these conferences, what I think is so fantastic here is to come and see the wide spread of things people are doing with it, much more than we ever dreamed of, at least I ever dreamed of. And yes, I can see we hit it right in some way, so you could do these things with it. But I'm still very impressed with what people do with the language, to be honest.
So one of the things that was really interesting was at the beginning, I knew that documentation was going to play a very important role in the adoption of Elixir. And you know, usually the way a lot of programming languages tackle documentation is that you have code comments. There's no distinction between code comments and documentation. So you have the code comments, you put the documentation in there, and you would need to have a tool that would extract the comments, right? And it kind of gets messy. And then I was like too lazy to do that, right? I already wrote a parser for the language. You don't want to write a parser that's going to handle the comments and whatnot. So I thought, you know, what if we get the documentation and have a way to associate it with the function? It's similar to how in Python we just have the here docs or the string with the function, and they are associated. And then, so I'm going to do this because it's going to be easy to write the documentation, and it's going to be very easy to access. I don't need to parse anything. It's going to be attached with the module, and people can just retrieve it, right? And based on the system that was created basically for documentation, it grew out to do a lot of interesting things. So someone brought doc tests that we have in Python exactly because since the documentation was so easy to access, they would access the documentation and they could extract the tests for it. So when you write the documentation and you have a test suite, we are going to test all the examples you have in the documentation to ensure it's up to date. And then they use also this annotation system, you know, to, if you're building an API, right, we can use this to add examples about how your API is going to work and be annotating the function with information that is not about your software, right, but people that are consuming and using your software.
Yeah, that's an excellent example, so it has struck me that that many of the features in Elixir and actually all these languages require they allow users to run with scissors. So what features very quickly would you categorize as great features that require great responsibility?
I'll start with that because it's easy. It's
easy.
Macros,
Yep.
right? So there is like, and I think it's important to have that. I don't believe like, you know, because at the same, when you take out the scissor, right? It's good because you can think it's good because, oh, maybe, you know, we won't have kids running with scissors, right? But at the same moment, you won't have your
scissors.
You won't have like Edward Scissorhands that can like do fantastic things with scissors, right? So you need to like have this. It's important to be there, and you need to balance that with education, which actually, if you're talking about children, exactly what you do, right? Like, don't play with scissors, and then you need to have care and educate about that. So macros is exactly this example, right? It's important to allow developers to get the language and extend the language and bring the language to other domains, but it needs to be education, and we work hard on that, right? There's like the first rule of the macro codes, right? Don't write macros. So that's like the perfect example that we can take from Elixir.
Yeah, being an old Lisp programmer, I completely understand the problems with macros, so that's yes. In Erlang, perhaps overusing processes. Sometimes you get people with a tendency to do everything in a process. They don't do a function call. They start a process to do the call, then sit and wait for the reply. That's going a bit overboard with it. I mean, processes are a wonderful tool for structuring your application, doing stuff, but they're not a replacement for function calls, for example. And sometimes people do use that. So yeah, that would be it. What else? No, I don't think so. That's about it. Should I have said something else?
I think, yeah, parse transforms probably.
Parse transforms are brilliant, right? it's macros on steroids, right? So every problem you can get with a macro, you can get it 10 times worse with a parse transform.
Well, so for Haskell, it's easy. It's lazy evaluation. So it's a wonderful feature,
Yes.
In my old paper, Why Functional Programming Matters, I wrote about it, and how you can modularize programs with it. You know, you can turn a loop into a producer function, generates a stream, and then another function that decides how much to consume. It's wonderful, wonderful for structuring programs. But what can happen is if you write, for example, a recursive function with an accumulating parameter, and you add 1 to it in each tail call, then you can run your program for 1 million recursions, and what you're doing is you're building up in your heap a huge expression that says, you know, 0 plus 1 plus 1 plus 1 plus 1 plus 1 1 million times, and then you wonder why your program's using so much memory. And, you know, at the end of the recursion, then you maybe return that result, and Haskell says, oh, I need to evaluate this after all. My God, I need to evaluate 1 plus 1 plus 1 plus 1 1 million times. Oh, I'm going to need 1 million elements on the stack to do that. And so you can run out of stack unexpectedly. You can be occupying a lot of memory unexpectedly. So that's probably a criticism that is made quite often. People will say, well, if you would just make Haskell strict, then your problems would go away. But it's not true, actually.
Right.
Because when you, if you want to use heap memory effectively, it's not always sensible to build your big data structures as early as possible. If you can build them just before you need them, that's more efficient. So it's a two-edged sword. And actually, the result of that is that when you have a Haskell program, we can put annotations in to make lazy things strict and strict things lazy. So it's under your control. And you can take a program which is needing gigabytes to run and put one annotation in just the right place, and suddenly it runs in 10K. And some people find that a little scary. Especially if you don't know where to put that annotation. And there'll be just one place in the program. And they'll say, if only the language was strict, and I knew the order of evaluation, I could figure out how much space was being used, and I could optimize it. But I like that. And the reason is that if you were to restructure the program in a strict language, you'd have to maybe restructure the program entirely to get that 10K behavior. But in Haskell, you only need to put in one character. The only question is where.
Is this another set of PhDs, or?
Yeah.
I thought that was a dollar sign.
It's a bang or a twiddle.
Oh, yeah. So for Python, actually, it's also the defining feature that is most easily abused. The dynamic typing is great, but you can also take it too far, and you can have programs that introspect themselves to the point of being completely incomprehensible to anyone who comes after you. And if that's what you're after, that's great. And sometimes it solves a very important problem. But most of the time, you should probably write a more tame version of Python where you don't use all the features of the language to the max, because no one else will be able to make heads or tails of it. And a sort of a special case of that is meta classes, which is super powerful stuff, but also hard to follow for those who come after you.
So let's see if we've prompted some more questions here. Questions? Yes.
Are you happy with your languages? I mean, most of your languages are not your child anymore. And are you happy with the current state of it? And the second one related, maybe you are writing a new language already, for example, Elixir++ or Haskell Sharp or whatever. So
So the first question was, are you happy with your language? Yeah, and are you writing a follow-up language now?
Well, I'm still getting Python 3 to be accepted. I'm not working on a follow-up language. I'm just working on 3.5, and after that comes 3.6, and then we'll see.
You see these gray hairs? Haskell gave me those. So I'm not actively working on evolving the Haskell design anymore. But am I happy with the state of Haskell? Yes, definitely. Yeah. I mean, in the research community, it's the dominant functional programming language completely. And it's actually, one year it was the 5th most talked about programming language on programming language websites in total, if you looked at some of these language ratings. So it's been hugely influential, and not just in the research community. And I think that's delightful. What I would like is, I'm very happy to see the position of functional programming in general now. I mean, remember, I've been doing this since before many of you were born. And when we started out, then we had this dream that functional programming could make developers an order of magnitude more productive. And I think that dream has been largely fulfilled. And
yes.
Now we're just seeing, of course, we're still seeing functional programming of various kinds being rolled out. The development is still going on. But I find that really, really exciting to see. What I wonder is, where is the next order of magnitude coming from? If I knew that, I would be designing a new programming language. But I don't have a good answer.
Yeah, I would agree with you on the impact of Haskell. On people like myself who have written just very small amount of Haskell, the influence has been just incredible on the way that I think. I remember in CodeMesh a couple of years ago, year and a half ago, Jose was talking with some Haskell developers on how to implement streams in Elixir. So it's so interesting and rewarding to see this kind of interaction across the programming communities.
I would say, look at this from 2 points of view. One is the actual Erlang language itself. I am sort of quite happy with the way it is. I mean, it follows a lot of the ideas we had from the original beginning. It's a very small language. That was a design goal. It's very concise. There's only one way of doing things, etc., etc. It does mean you have to do a lot yourself explicitly, but then it is explicit and it's easy to see things for it. So in that sense, well, another factor for the language development is, yes, it's being used in products. Many products they expect to live a long time, so you have to be very careful when you're developing the language. I mean, this backward compatibility thing is, yes, it's a great pain, but I know that in a couple of years' time I can still run my system on Erlang because it's going to be backwards compatible. In that sense, it's a big win. The other side is, I would say, the language, the Erlang system, both the virtual machine and the OTP libraries and the whole way of building architectures. That's another part of the system. That is coming along very nicely. I mean, yes, there are probably some mistakes in it, but it's coming along very nicely. It also means that you can build other languages on top of the Erlang system. I mean, Elixir is one example. For those of us who like parentheses, you can do list-flavored Erlangs, do that. They both work on the same idea. You have this underlying layer of a system, of a virtual machine, a system you can build something on top of to make it look more like what you would like it to do. I find that's very good. And also, well, a third point here is that the Erlang system is very open to doing things in other languages. And we are, from the very beginning, very early been that, don't write everything in Erlang, because Erlang's not good for everything, but it's very good for talking with other things. If you have something written in Python, which is perfect, fits Python perfectly, don't waste your time translating it to Erlang. Interface Python to Erlang instead and use that. Right? The same thing with Haskell, whatever. So to do that, so that in a sense removes the necessities for working with a language. So just a slight comment.
Jose, I want you to skip the first question and go to the second. What new language are you working on?
Yeah, so Elixir reached 1.0 just less than a year ago. So if I said no to the first question, something would be really, really wrong. Yes, I'm definitely happy with it, and I'm going to explore that from two sides. The first one is that there are like different kinds of 1.0. So there's a 1.0 like, you know, I'm releasing this, but this is like is the first point of 1.1, 1.2, 1.3, and we are kind of still finding our ground. And for Elixir, it was not that. It was this is 1.0, and this is the foundation. We are going to build everything. We are going to build the rest on top of. So my talk, for example, yesterday was exactly how we have laid this foundation and how we are exploring it in upcoming Elixir versions. So I am actively, I'm still actively working on Elixir, and I think I have like 2 or 3 years of work already that I want to put in there and of things that is going to be on top of this foundation. Right? So that's like one source of happiness, like finding this foundation and be sure that's the ground you can build everything on top of. And the other one is exactly here at the conference, right? We can hear a lot of people using Elixir in production. It's just fascinating, like in embedded devices, people building web applications, some financial systems also already using Elixir, and that like brings a lot of happiness for such young language. There is not even one year in 1.0 yet. So yeah, and just I was not sure if I was going to say that, and if there is another programming language, I'm not sure I would ever design another programming language, because it's very tiring, because as an engineer, I look at it as an engineer, right? And there is a problem, and as an engineer, I want to find the best solution to that problem, but there is no way I can design the best programming language for a particular problem. And that's very consuming because there are so many options we can take, so many decisions, right? It's like kind of like a Jenga game that we need to be very careful, right? Because, or if you put something wrong or if you take something wrong, everything falls apart, and you need to understand how the pieces, they really come together. So, and we take those decisions and we're not sure, like there's a lot of feeling, I think this is going to be better, right? And then a week later, you launch that feature, and then a user asks, hey, why you didn't design that way? And then you kind of go back, like, why I didn't design that way? And try to reevaluate that feature and think it over and over again. So someone asked, like, have you ever thought, if you had this differently, like this particular feature? And I say, like, probably like 100 times, because it always, and that process is very, I find it very consuming. And I think the nice thing about Elixir and building on the Erlang virtual machine is exactly, so it was already hard in terms of like the design decision, a bunch of decisions you could take, but the virtual machine took a bunch of those decisions for me. If I wanted to run the Erlang virtual machine and I didn't want to break hot code loading, there were like a bunch of decisions that they were already taken and made it much easier.
So the person that posed the question, I like the word happy, and I remember a point with the Elixir conference this year. We were in Austin and we were at a table and we were looking at each other and asking the question, did we just hit critical mass? And it was a really cool moment. Really cool moment. Question here?
Yeah. It's about the design of Elixir. Elixir seemed to have a unique method of design, which I've never ever seen before, and that was the co-design of the language with the book. So if you look at Erlang, Erlang was designed, and the first book came, I think, 14 years after the design of the language. Now, when you write a book, you suddenly get insights into the language design, because when you're writing the book, you say, oh, I can't describe that, and you change the language design. But Elixir has been co-designed. I mean, you've done the language design with the book, so Dave Thomas has written the book. And Bruce, you write books. And we use different tools for writing books and for writing programming languages.
Yes.
Do you think this is beneficial? And do you see that sort of leading the development of programming languages in the future?
So that was very interesting because all Elixir development was always open. It was open source since the beginning. The bad side of that is that all my mistakes, they are in the repository. So the prototype I talk about, it's there. Don't go look for it. You were warned, but it's there, But the nice thing is that as the language people started to play and started to use it, we created this Elixir Lang core mailing list where we would have discussions. And for a good period, every time we wanted to add a new feature to the language, I would write a proposal, often discussing different solutions. And then Dave Thomas, as a book author, he was there. Simon as well. And, you know, I would send those proposals, and the community would give feedback. Like, yeah, this feels good, this doesn't feel good, maybe you should change this. I think one of the most interesting parts was when maps, they were added to Erlang, and we were based a lot on records, and then that map, since maps were added, we say, like, we have an opportunity, we are not 1.0 yet, we had the opportunity to reevaluate this this important part of the language. And it was a very nice process because I wrote one proposal, and then people said, I don't feel that this is it. And then I wrote another proposal, and they, it doesn't click yet. And I think it was like the fourth or fifth proposal where, and basically what they did is that my proposal, they were trying to make like those two things work together, not change a lot. And then I said, okay, I'm going to throw everything away and write a proposal completely from scratch. I sent it to the mailing list, and then everyone said, this feels correct. This feels like this feels Elixir, and this feels like it's going to fit with everything else. And that was a very fun part of this whole process to, you know, it helped exactly what I was saying, right? It's hard, and then if you can get this feedback early on and try to bring a lot of, you know, contributions and developers, it makes the process easier too.
Yeah, because kind of follow up. Sure. Just a reflection that all the languages that we've done were done through before the internet really exploded. So the dialogue that Rob and I were talking about Erlang every day, but it was just the two of us, and the Haskell dialogue was taking place in a small committee, and presumably when Python was developed, there was a very small number of people involved in that development. You have long, intimate discussions with people about it. But when Elixir's evolved, this is one of the new generation of language where that process takes place in a much wider forum. And I'm seeing already, I think, you know, the benefit of that. And I think that's going to be great, actually.
Actually, you mischaracterize Python's development, because even though, yes, ABC was designed very much in that style that you describe, in 1990 there was a little bit of internet. That was actually one of the big things that helped Python. And sort of, I think, right after we released it for the first time, we created a mailing list because there were so many people interested in sort of helping out, using it, learning it, but we immediately attracted a lot of people with language design and implementation sort of experience and good advice, and a lot of very cool stuff in Python actually came through that community. So the community has always been a very important part to Python's development.
So I'd like to thank the panel. One more comment.
So one quick question to you. How do you keep focus? If you're developing the language in a community, how do you keep focus of the language of where you want it to go, where you plan it to go, right? And not just sort of completely diverge and split out into be something like PL1 with 50 million options for everything, right? I don't have an answer to the question. I don't have an answer.
That's why they nicknamed me the BDFL.
Yes. It's not a democracy, right?
Exactly.
Yes.
You got to be pretty boneheaded about it and sort of listen to everyone, but then do your own thing.
So I'd like to thank the panel so much for this conversation. It's a very rewarding thing for us, but it's a difficult thing to lay bare those decisions, and I want to give them a big hand.